talk about radians. Radians are used in calculus rather than degrees because degrees are base 60 or some Babylonian number system, and radians are base 10. So they're easier when we're doing derivatives and things like that. So if you want to continue thinking in degrees and convert to radians all the time, that's fine. That's what I do with the metric system because I'm used to Fahrenheit and I convert to Celsius rather than thinking in Celsius. But if you can start thinking in terms of radians, that would be great. So what is a radian? Well, Mr. Haas?
It kind of sounds like radius.
Yes.
Is a radian and a radius somehow associated?
They are.
Oh, all right.
So if I take a radius, give me a length for this radius.
2
centimeters.
miles.
2 miles.
Oh, yeah.
Okay,
Big circle.
whatever.
Big circle.
Okay.
Okay.
2 miles. If I measure that distance exactly, I'm going to use my little string here, and then I measure that distance exactly around the circle until where it ends, right there, that angle of rotation right there is defined to be 1 radian. 1 radian. A little less than 60 degrees if we're in degree land. It's like 57.29 something degrees.
So a radian is a degree, it's a measurement of how open that angle is. It's
Exactly.
an angle, it's like a degree measurement, right? Okay.
Yeah.
It's not, it's really not a distance.
It's not
right?
really
Okay.
a distance, it's really a rotation.
Got it, all right.
It's really a rotation.
And if instead of being 2 miles, if it was like 5 inches,
Sure. It wouldn't change.
It'd be the same thing.
That's still 1 radian.
Got
1
it,
radian.
all right.
So, if I took that 1 radian, let's see, about how many of those do you think would fit in one circle? So there's 1 radian, 2 radians. Oh, wow.
Well, 3 would maybe maybe I need a little bit more than 3 to get halfway around the circle.
All right, that looks like about 3-ish radians. All right, so that means about how many?
About 6 would go all the way around, maybe?
6-ish radians would be all the way around a circle. So there are a little more than 6 radians in a circle, right? 1 radian, 2 radians, 3 radians, 4 radians, 5 radians, 6 radians. Now, of course, it's 6-ish. We can be a little more specific. Circles always have what in them?
Pi?
Pi! And if we think about this being a unit circle, I can think about the circumference of this circle as being 2 times pi times 1, 2 pi r. If you remember, the circumference of a circle is 2 times pi times the radius. So if I'm in my unit circle, my circumference of the circle will be 2 pi. Hey, 2 pi? What's pi about?
About 3, maybe slightly bigger.
3.14159-ish, a little bigger than 3. Something a little bigger than 3 times 2. That sounds about right for how many radians make up a complete rotation. Sure, there are 2 pi radians in a full rotation around a circle. And that makes sense because lots of times our radians of our nice angles, like 30, 45, 60, 90, have pi in them. So many times students think that radians have to have a pi in them. They don't. You can talk about 1 radian, or 2.5 radians, or 5.75 radians. And in science, lots of times you do. In math, whenever we want to do calculations without a calculator, you have to have nice angles. So that's why we often see radians with pi in them. All right, so our 3-ish radians, I guess all along, that's been pi radians, 3.14159 radians. Okay, so that makes, let's just break it down. Okay, so if it's pi radians, that means when I go 90 degrees, I've gone, oh, half of pi radians, right? I'm going to keep writing radians. Usually you don't use any units for radians. It's just implied that it's a radian. Okay, if I go 3/4 of the way around, what's that going to be? Well, let's see. I have 1/2 pi, 2/2 pi, 1.5 pi, also known as 3 pi over 2, and then 2 pi. So you can kind of fill in your radians here. Is this making sense? Let's break the circle into fourths. I shouldn't have said 3/4 of the way around. Let's break this into fourths now. All right, so if this is pi over 2, this is going to be pi over 4. So my 45 degrees is in radian land, pi over 4 radians. Is this making sense? 1/4 pi, 2/4 pi, 3/4 pi, 4/4, 5/4 pi, 6/4, 7/4 pi, and 8/4 pi, otherwise known as 2. And I can keep doing this and get my 30 degrees, my 60 degrees, and all of those multiples as well. Let's go ahead and just put the 30 and the 60 in because those show up a lot. Okay, now with that 30, I'm breaking everything up into, I'm breaking my half into sixths. That's a sixth of a pi. That's the same as 30 degrees. My 60 degrees is the same as pi over 3, etc. Okay? If you forget pi over 3, let's see, what is that in degree land? What's pi over 3 in degrees? You can always think, hey, pi is halfway around the circle. In degree land, that's 180 degrees. So you can kind of just think, oh, that's 180 degrees divided by 3, that's 60 degrees. So pi over 3 is the same as 60 degrees. It's really easy to convert back and forth. So those are your radians. Now, when you're working with radians, you just have to keep telling your brain over and over and over again, the radians are the angle. It's not the ratio of sides. Because it looks like a fraction, people get confused. Oh, that's your ratio of sides. No, that's your angle. If you want to find the cosine of pi over 4, you're looking for the ratio of the side next to it, the adjacent over the hypotenuse, when your rotation is pi over 4 radians, 45 degrees. And there you have it.